Hello there, welcome to the webinar. I'm Jack Cannon, President of the British Society of Soil Science, and I'm really delighted to welcome you to our 7th webinar this year. Before I welcome our presenters, I'd just like to introduce the British Society of Soil Science. We're host of today's webinar, and we're an established membership organisation and charity, and we're committed to the study of the soil in its widest aspects. And we bring together those working in academia, and we've got a really big growing membership amongst practitioners who are implementing soil science in industry. And we also obviously welcome anybody that has a keen interest in soils to join the society too. We'll be hosting 8 webinars during 2023, so keep an eye out for our last one on the website for further details. And just before we begin, just a bit of basic housekeeping. We've got a lot of you on the call. Your microphones have been muted. And we will take questions right at the end of both presentations. And we'll be monitoring those throughout the webinar. So do pop your questions as we go along in the questions box, and just try and do that by 12:50. And that will allow us to get through as many as we can after the 2 presentations at the end. You might have noticed there is a raise your hand button, but we're not going to use that during the webinar unless the presenter specifically asks for a show of hands during their presentation. Today's webinar has been awarded both BASIS and NRSO CPD points. So if you're registered with either of those, please do contact us after the event so that you can be awarded your CPD points for the webinar. And just to make you aware, we are recording today's presentation. It will be available on our YouTube channel after the webinar. So enough from me. I'd really like to welcome our first presenter. This is Professor Deyi Hou, and he's head of the Soil and Groundwater Division at Tsinghua University, and he's serving as the Vice Chair of the UN-FAO International Network on Soil Pollution. And his research is focused on contaminant transport and distribution, both in soils and groundwater, synthesis of innovative environmental functions and materials, and green and sustainable remediation. He's conducted numerous projects involving soil and groundwater pollution, both at site, regional, and national level. He's published over 5 books, 200 journal papers in top journals including Nature Science, Nature Climate Change, Nature Sustainability, Nature Review, amongst others. And we're really delighted that Deyi is currently serving as the editor-in-chief for one of our journals, Soil Use and Management, and he's also an associate editor for Science of the Total Environment. So I'm really excited to hear what you've got to say, Deyi. So it's over to you to do your presentation.
Thank you, Jack. Do you see my screen now?
Yeah, that's absolutely perfect. Yep, go ahead.
Okay.
Great, thanks.
Great. Good morning, ladies and gentlemen, my friends. It's a great pleasure to talk at this seminar series. Today I'm going to talk about the green and the sustainable remediation of contaminated sites. I have been studying sustainable remediation since I did my PhD over a decade ago at the University of Cambridge. It's a great joy to talk to our friends in the UK about this topic. First, I want to give a short introduction. You probably all are familiar with soil and the United Nations Sustainable Development Goals. And if we look at this chart, we can see that soil pollution can affect a number of SDGs, ranging from no poverty, zero hunger, to climate action and biodiversity, and so on. Brownfield site pose a particular challenge to soil pollution prevention and mitigation. Globally, Based on existing data and some regression analysis, we estimated that there are over 5 million brownfield sites. In China alone, we estimate there is over 1 million potential contaminant sites. The remediation of contaminant sites has started since the last century. The primarily begin with a few high-profile cases in the U.S. and the Netherlands. One of the most famous one is the Land Canal incident. And because of those high-profile cases and the public pressure, during the early days, the remediation industry mostly take a remove all approach, which means that the public and the regulators want the polluters and the remediation parties to remove all contaminated media, including soil and groundwater, which was found later to be unfeasible. One example is for groundwater remediation, it's extremely difficult to reach the maximum cleanup level in the MCL in the US is a drinking water standard. So in the 1990s and 2000s, the risk-based cleanup approach is increasingly adopted. And it also aligns with an initiative for sustainable land management. More recently, the remediation industry are increasingly looking at sustainable remediation. So if we look at this chart, we can see scientific literature related to green and sustainable remediation has grown rapidly over the last decade or so. It's pretty much in exponential growth. And during this period, we can see in the early days, life cycle analysis paved the way for better understanding of what sustainability means for the remediation industry. And in 2006, the Sustainable Remediation Forum was first founded in the US. Also US EPA and many other governments all around the world are establishing policies and regulatory requirements around sustainable remediation. There are also a few international standards, including the ISO standard, which I'm sure Paul will talk in the next presentation. Next, I want to talk about the life cycle net benefit of remediation. First, let's look at the definition of sustainable remediation and green remediation. Sustainable remediation is more broadly adopted in the remediation industry all around the world. And its main message is to maximize the overall environmental, social, and economic benefits of remediation. Green remediation was more widely adopted in the US. And it is mainly looking at the environmental benefit, more specific, the net environmental benefit of remediation. So to support green and sustainable remediation, it's essential to conduct some sort of sustainability assessment, either quantitative or semi-quantitative or quantitative. And a core value of sustainability assessment is to capture the externalities that are not included in the traditional decision-making framework. For example, when we talk about remediation, we rarely talk about carbon emission or soil biodiversity or air pollution associated with the manufacture of the equipment or the materials used in remediation. And all these are considered the externality that are part of the remediation life cycle processes. in the ongoing movement of sustainable remediation, and we ought to capture these additional factors. This is a chart taken from a USCP publication. It shows 3 levels of considerations around remediation. Level 1 is at the middle of the chart. It shows the processes occurring at the contaminated site. And level 2 is the transport process associated with the materials that are used at the site. And the third level is the process in which people make the raw material and the equipment. This level 3 activities may occur thousands of kilometers away from the contaminated sites. In order to do a holistic sustainability assessment, we need to go beyond some existing boundaries in traditional decision-making processes. One is on the spatial scale. While traditionally, we mainly look at the on-site processes. For sustainability assessment, we need to look at regional, even global impacts, for example, the greenhouse gas emission and global warming potentials. On the temporal scale, we need to not only look at the current site use, but also the future site use. And also, when it comes to the impact category, we need to look at the environmental, but also social and economic impacts. And there are also 3 levels of impact: the primary impact, secondary impact, and tertiary impact. These are special terms that we are using in the remediation research community. Primary impact refers to the impact associated with the physical state of the site, and quite often we can use risk assessment to evaluate some of those impacts. The secondary impact is the life cycle impact associated with the remediation processes, which reflect the chart that I showed earlier, which was taken from the USCP, different levels of secondary impact. And a third level, which is still not widely done, refers to tertiary impact, is a consequential impact of remediation. It matters due to the change of site use. So that's why it is a consequential impact. The next challenge I want to talk about I want to show the reason of talk about the green sustainable remediation and sustainability assessment. Traditionally, we use the health risk assessment now more than a few decades, but there are some shortcomings. For example, it doesn't relate the risk of contaminant level with the volume of contaminated media. As I show on this, the 2 figures below, for site A and site B, the marginal benefit differs greatly. So in theory, we should allocate different levels of resource for the remediation of these 2 sites to achieve different remedial goals. But in reality, we often only look at in arbitrarily set levels. For example, in China, we always look at 10⁻⁶, which is not necessarily the best value for the whole society. And another factor is the level of efforts quickly increase as the remediation standard becomes more stringent, especially on the lower end. So combining these 2 efforts, we can see that the difference between the benefit of the remediation and the environmental cost of the remediation is the net environmental benefit. And this net environmental benefit needs to be maximized during the sustainable remediation decision-making process. And here we're showing a study that we did, which showed that on the different cleanup levels, the net environmental benefit can maximize at a certain level. It's not necessarily the better with a lower or more stringent cleanup level. Now, I want to talk about a case study about the primary, secondary, and tertiary impacts. Again, I already talked about the definition of primary, secondary impacts, so I will skip this slide. So we did this study for city level assessment. We chose San Francisco as the case study site. For the primary impact, we look at the contaminant degradation, landscape change. For the secondary impact, we look at the on-site and the off-site remediation, disposal, transportation, and etc. For the tertiary impact, we look at the site preparation, utility rework, energy intensity in the operation. In order to capture the tertiary impact, we have to have a comparable baseline. And in this case, we choose greenfield sites as a supplement of contaminant site remediation in order to get the net greenhouse gas emission. We also use the GeoTracker database, which, by the way, is a very good database in the US, which through which we can search for data for all the contaminant sites in California. So we used that to get data for the city of San Francisco. And we also obtained a number of parameters for electricity, natural gas usage, and fuel usage, and so on. This figure shows the estimate for individual sites, and this shows the combined results. As we can see here, for this city level assessment, what we found was that the secondary impact was quite significant, way more significant than the primary impact. However, a surprising result, to ourselves, is that the tertiary impact was over 1 order of magnitude higher, which really shows the importance of including the consequential impact of remediation. Some summary of the findings: the secondary impact is significant, tertiary impact is even higher. Most importantly, we found the climate change mitigation potential by doing this sustainable remediation operation at the city level can reduce the annual emission of greenhouse gas emission by 14% for 70 years, which can be really pivotal for realizing the zero emission goal of the city of San Francisco. Next, I want to talk about sustainability assessment for an individual site. We did this study for a mega site in China, and we built the sustainability indicator framework with both international consensus on various sustainability considerations, but also we included country-specific considerations in China. We established a system boundary for 2 different alternatives. One is soil washing, and other is excavation and off-site disposal. And this chart shows the inventory results. Here we are showing the process contribution. As we can see, for the different alternatives, excavation and off-site disposal, excavation accounts for a significant portion, but the majority is attributed to hazardous waste disposal. For excavation or off-site disposal, in this case, because some of the contaminants were removed in soil washing and some other were removed in thermal desorption, we can see the energy consumption in thermal desorption caused a big portion of the overall environmental cost of this alternative. So by doing this, we can come up with better solutions. I mean, first of all, is to select the optimum between different alternatives. Another is, I mean, more recently, we are seeing increasing interest in nature-based solution. And these nature-based solutions can offer great social, economic, and environmental benefits. Just to give a few examples, here in this case, practitioners use the constructed wetland to treat the contaminated water at a brownfield site. And in this case, people are combining landscape design with phytoremediation. And in this case, practitioners develop brownfield and converted it into industrial heritage park. So these nature-based solutions really offer a lot of benefits. But on the other hand, we also need to look at the resilience of different remedial alternatives, including nature-based solutions. We did one study for a study site in the San Francisco Bay Area. And what we did was to evaluate a phytoremediation system along the coastline. It saved a huge cost for the site owner. We estimated that the phytoremediation system can save over 90% of the cost in comparison with bioremediation or in situ chemical oxidation. However, we also want to look at the scenario of global change, more specifically the rising sea level, because the phytoremediation system in this case is a long-term risk management system. And what we found was that under low or moderate level of sea level rise, the system has good resilience. But under high sea level rise scenario, the system can passing the tipping point and fail abruptly. Toward the end, I want to talk a little bit about the adoption of green and sustainable remediation, both globally and in China. Here, I'm showing a survey study that we did several years ago. What we found was that in developed countries, the adoption rate is relatively high, and in developing countries is still relatively low. We also did a survey in China. We found that people have heard of or know something about green and sustainable remediation. And nearly all the survey participants, we surveyed nearly 300 participants, remediation practitioners in China. We found that nearly all of them consider sustainability necessary in becoming a criteria in choosing remedies. However, it's not effective. It's not effectively being adopted in China. And with that in mind, I led a team in China to develop the first green and sustainable remediation technical standard. We started to work on it in 2016. After 4 years, we were able to publish it in 2020. And this is a screenshot of the final technical standard. So for the future, in order to promote green and sustainable remediation, we think we need to educate both college students and professionals and the general public. As for technology development, we needed to conduct more research on in situ remediation, which tended to have a smaller environmental footprint. We need to minimize the energy and material consumption, develop innovative green remediation materials, and probably we also need to promote the adoption of monitoring natural attenuation techniques. I think I probably have like 1 minute left. I want to give a short introduction of INSOP, the International Network on Soil Pollution. INSOP aims to facilitate the global agenda on stopping soil pollution and achieving the global goal of zero pollution. We want to work with our members to improve knowledge on the full cycle of soil pollution from assessment to remediation, as well as on the effect on environmental and human health and the provision of soil ecosystem functions and services. We aim to strengthen technical capacities and the legislative framework for the prevention of pollution and to promote the exchange of experiences and technologies for sustainable management and remediation of polluted soil. And on this slide, I also have a barcode. You're welcome to scan the QR code to join INSOP. There's a very short survey form. Once you submit that survey form, you will automatically become a member of INSOP. You will receive regular update on INSOP activities, and also we send out newsletters about global activities on soil pollution. And also we regularly organize seminars, conferences, and we also have several working groups which we plan to work on a number of technical guidelines, standard operating procedures, and etc. You're welcome to join INSOP and join our working groups to contribute to this global effort. Thank you very much.
Well, no, thanks very much. Thanks to you, Deyi, for absolutely fascinating talk, particularly introducing the concepts of sustainable and green remediation. I've learned quite a lot actually doing that, and really great to see all those case studies, and particularly those sort of tertiary impacts as well, doing the life cycle analysis. I tend to think at the site level, but actually looking beyond that, it's really, really fascinating. So yeah, thanks very much. So I'd just like to remind you all that we'll be able to ask questions at the end, so after Paul's talk. So if you've got any questions for Deyi, please type them in the question box and I'll come back to them at the end after Paul has finished his talk. So on to our next speaker, who's Dr. Paul Nathanail, and he's a specialist in land condition and a suitably qualified person under the NQMS, and he's also a chartered geologist. He's director at the Land Quality Management Ltd, and this company offers his specialist services in the assessment and remediation of contaminated sites. He's got a long-standing interest in improving professional standards, so that links quite nicely to Deyi's last slide on education, but also particularly professional standards specifically in land contamination risk management and sustainable brownfield regeneration. He's consulted on and provided expert evidence for many landfill redevelopment projects. And finally, he led the team who wrote the ISO standard on sustainable remediation. So really delighted to welcome you, Paul, and over to you. Thanks very much.
Thank you very much indeed. I think we're going to go from the global and the city scale down to the site scale in what I'm going to talk about. Thank you very much for the invitation. I'm delighted that as a member of the Society to see soil and remediation being given the kind of profile that this webinar is giving it. I have a broad background, spent 25 years as an academic, ending up as the Professor of Engineering and Geology at the University of Nottingham. Working with the Geological Survey, I run a European brownfield network called Cabernet, and next week I am in Melbourne giving the closing plenary at the Eco Forum SUSTREM, the International Sustainable Remediation Conference in Melbourne on Thursday evening Australia time. That's LQM. We do all kind of cool stuff. Well, that's not what you're here to listen to. The process of land contamination risk management involves an initial stage of risk assessment, a diagnosis, if you will. Houston, we have a problem. Stage 2 is the process of prescribing a solution, so identifying feasible options, evaluating them and choosing. And then stage 3 is the actual remediation itself. It's the operation or the taking of the medicine, where you develop a remediation strategy, implement it, and provide a verification report that everything went hunky-dorily. The structure is the structure of guidance that is followed in the United Kingdom, and the link to that is at the bottom of my slide. I've highlighted in gold where sustainable remediation comes in, and in green where greening your remediation comes in. So we've already established that there is a problem. The risk assessment tells you that there is a need to remediate. How am I going to remediate? Well, I have to have a feasible option, and then I can choose how I'm going to evaluate my short list of options. I might look at the cheapest, the quickest, or I can look at the most sustainable of my shortlisted options, and then I need to choose that option. Having chosen that option, you then enter into a process of designing what you're going to do, getting the permits and everything else, and at that point, you can look at greening your remediation strategy, and there's some excellent guidance from the US Environmental Protection Agency on how to green your remediation strategy. Alongside that, you can also value engineer it. You can look at where the money is being spent and when it is being spent, and see if you can achieve the same thing, but without spending that level of money. So I'm drawing a very big difference between sustainable remediation at the options appraisal stage and then greening the chosen option at the detailed development and design stage. The International Standards Organization definition involves recognizing the need to manage your risk, demonstrably breaking that source pathway receptor relationship. And the way that we describe that as sustainable remediation, I seem to have, there we go, is by managing that risk by either eliminating or controlling it in a safe and timely manner. That's just good remediation. What makes it sustainable is balancing the environmental, the social, and the economic value of the work. You cannot maximize all three. That's impossible. But you're looking for a sweet spot. And the definition of unacceptable risk is a matter for the law, the government, the jurisdiction of the area that your site sits in. The international standard, which has also been adopted as a British and Australian standard now, provides a standard methodology for identifying the most sustainable option and defines words so everybody means the same thing when they use a particular word. In philosophical terms, we're looking at the relative sustainability of different courses of action, of different remediation strategies. And we recognize the importance of promoting sustainable remediation early in the planning stage of a project, and then later on in the implementation stage as well. What the standard does not seek to do is tell you how you must do the assessment. Life cycle analysis is a really sophisticated and expensive way of looking at things, and if you need to do that, then great, but do it as simply as possible. Famous English monk Ockham talked about, if you've got two alternative courses of action or two alternative solutions, choose the simpler one. It doesn't tell you what indicators you must use or how to measure them. And it doesn't delve into the green or green and sustainable remediation domain for the reason that I've shown on the previous slide. So, where does the ISO come in? It follows on from risk assessment. The risk assessment says we need to do something. It provides a standard methodology, and it provides advice on identifying the relative sustainability of different options. It does not mean you do less remediation. It does not prescribe, it advises and encourages. So the Sustainable Remediation Triathlon, in the year before the next Olympics in Paris, there are 3 competitions, 3 events going on at the same time. For sustainability to have any meaning, you need to look at the environmental, the economic, and the social pillars. So what you're looking for is greener remediation, cheaper remediation, and more socially acceptable, more popular. And I know that's not how you spell it, which is why I put my E in italics, but I wanted to be poetic. And what we're looking for is to be here. That's the sweet spot. And you can see that there is a compromise, there is an optimization across those 3 domains. Now, I'm a big fan of Humpty Dumpty. Lewis Carroll, in Through the Looking Glass, quotes Humpty Dumpty, who says, "When I use a word, it means just what I choose it to mean, neither more nor less. The question is, which is to be master? That's all." And in this space, words really matter, because if we use the same word but mean different things by it, we will not be communicating very well. So I want to draw the difference between sustainability and sustainable. And I'm talking today about sustainable remediation. Sustainability is a noun. It's in the ability to be maintained at a certain rate or level. In natural earth system science type of thinking, it's about avoiding the depletion of natural resources, and the balance we're trying to maintain is an ecological balance. It addresses the concept of the ongoing capability of the planet to maintain life, not just human life, but all life. Sustainable is an adjective. It describes something. The Brundtland definition talks about sustainable development. Here we are talking about sustainable remediation. So, working with the ISO definition, how are we going to put that into operational practice to help us make decisions? Well, in remediation, what you must do is eliminate or control the risks, and do that in a safe and timely manner. What we want is to do that while looking at the environmental, the social, and the economic dimensions. So you have to do that, otherwise it's not remediation, and it would be good if we did it in this way. Sorry, I got diverted by a flashing chat box. I want to look at what might be unsustainable remediation, because that might help us when we think about what might be sustainable remediation. So unsustainable remediation is really expensive. Just costs more than we can afford. It upsets people, or it leaves behind a damaged environment. And I can think of examples of all 3, and maybe in questions we can bring that out. The other type of unsustainable remediation is failed remediation that just didn't do the job. It didn't remove or control the risk, or it left behind so much uncertainty that we're not sure if the risk was managed. And I would argue that most phytoremediation would leave behind enough residual uncertainty to question whether it succeeded or not. There you go. There's a challenge for discussion in a minute. This is the structure of the ISO standard. It's only 24 pages long. Its scope, every standard tells you what it's about. And it's about the relative, the comparison between alternative remediation strategies. So some very important definitions. An indicator is a characteristic that allows us to compare 2 or 3 more alternative remediation strategies and say, This strategy is better than this one on the basis of this indicator. It could be carbon footprint, it could be jobs created, it could be the net present value of the overall remediation cost. The metric is how you're going to measure that indicator. So if you have something that doesn't separate out, doesn't differentiate two or more options, don't waste your time trying to measure it because it's not going to help you. The governance context under which these decisions take place is really important. The legal context, the legislation, the law is primary. You have to have remediation that complies with the law. Then you have institutional missions, in commercial terms, the ESG policy of an organization. Recognizing that what might work in one part of the world may not work in another, and that the technical outcome has to be acceptable to public authorities and the public. Keep it simple, and the standard says that in quite strong terms. The simplest is qualitative evaluation. I'm not a very great runner, but I really enjoyed watching Usain Bolt, the world's fastest man, over 100 meters, win race after race after race. You didn't need a photo finish to see that he had won the race. There was enough gap between him and the second place person that Usain Bolt was the clear winner. Keep it simple. You might need to go to a semi-quantitative approach using things like pairwise comparison and multi-criteria analysis. Very, very rarely do you need to go to a fully cost-benefit analysis or a full life cycle assessment. Those are resource-intensive, time-consuming, expensive steps that don't help most of the time. So a simple example. We have a heating fuel delivery to a house that went wrong, and the fuel was spilt. It's polluted the groundwater in a shallow sand and gravel aquifer. The water table is at 3 meters depth, and the free product has already been recovered, so we're really worrying about what's dissolved in the groundwater. So the risk assessment says we've got contamination in the groundwater and we need to do something about it. The shortlisted feasible options are air sparging, biosparging, or monitored natural attenuation. So we're going to compare those three and see which is the most sustainable shortlisted option. So I could do pairwise comparison, where I say comparing option B against option A. And you can say B is 3 times more cost effective than A, and so on. So we have a number of dimensions. We have cost effectiveness. We have social acceptability. Oops, up here. Looking at 4 dimensions now, we have the economic, we have the social, we have the environmental, and because I've got 2 matrices with 4 halves, I had a 4th bit. So over here, I had the ease with which you can verify that the remediation worked. And what we've done on here, and this is an exercise I've done with groups, both professionals and master's level students, we've compared those 3 shortlisted options. And what we see, that there is an obvious winner. Of those 3 options, monitored natural attenuation comes out time and again as being better than air sparging and biosparging. So under cost effectiveness, M&A is the cheapest, it's the most socially acceptable, it has the lowest environmental impact. It is, however, because it's a long-term process, the one that would lose out on the ease of verification. So we have 3 gold medals to M&A and 1 to air sparging, and therefore on that basis, M&A comes top of the medal table. So a checklist. If somebody claims they are doing sustainable remediation, and you'll see that in papers and advertisements and so on, check. Have they thought about all three dimensions? Or do they simply mean something is quite trivial or only a partial answer? Claiming that I'm using renewable energy is good, but it doesn't make it sustainable. It's a little bit cheaper is good, but it doesn't make it sustainable. We reduce the number of times we drove to the site in a diesel-powered vehicle is good, but it doesn't make it sustainable. We produce less waste. We invited the community in for an open day to look at what we were doing and be transparent. Great idea. It doesn't make it sustainable. It's bioremediation, and bio must be a good thing. Well, it may be, but it doesn't make it sustainable. So this is a checklist that the team in Surf Australia, New Zealand, of which I'm a member, came up with, a checklist for using the international standard, which is also an Australian standard, on a site. Make sure that you've got clear objectives. You end up with a short list of things that could do the job. You then agree the indicators for those technologies at that site, and that those indicators work for a combination of technologies into a strategy. You look at your three dimensions, come out with your overall appraisal. If there is a clear winner at a simple level, great. Document the process. How did you end up with your preferred option? And then go on to stage 3 and develop the detail, green your remediation, value engineer it, design it, implement it, verify it. Be careful. Be aware that no technology is sustainable. It's a site-specific decision. Be careful of people who just use sustainable as a flavoring because it sounds better. Be careful that most of the work is done by people who have a science or an engineering background, not an anthropology, social type of background. Be careful that local people's views, what we call the social license to operate, is difficult to obtain, difficult to maintain, and very easy to lose. So, penultimate slide before we move on to the exciting part of the webinar, which is your chance to ask us questions. I hope I've given you an insight into how to make this operational. There is more that can be done. Things that I'm working on at the moment are carbon footprinting different remediation technologies. Just finished that work. Hopefully it will be published in the next couple of months. And then looking at both climate change and the extreme weather events and how they impact on option appraisal and on the implementation of remediation strategies. And this is work that we've done for the Environment Agency here in the UK, and that I'll be talking about next week in Melbourne in the closing plenary of the SUSTREM conference. Now that's on the remediation side. On the risk assessment side, if we knew the risks better, so doing a better preliminary risk assessment, a more accurate quantitative risk assessment, and better constraining the extent and the depth of remediation, then we would make sure that we were doing as much remediation as was needed and no more, and we could choose the most sustainable way to do the right amount, neither too much nor too little remediation. So with that, I'm going to thank the Society again for inviting me to be part of this webinar and hand back and hopefully get some questions from you.
That's really great. Thanks very much, Paul, for taking us through that. I'm sure it took a very long time to come up with the standard. I've got a couple of questions about that. This obviously is the Q&A session, so both Paul and Deyi are available to answer your questions. So do submit them. Please type them in the questions box because you're all muted. so I will read them out on your behalf to the panelists as well. I've got one, but maybe a couple actually of questions. There's lots of fascinating things. So one for Paul first, I think you alluded to it in your presentation, but can you give us some examples then of unsustainable remediation?
Yes. Let me give a particular example of very unpopular remediation. A site in a part of the UK where the process of choosing the remediation option was discussed with the local community. Each step of the way was agreed, and when they came up with the final answer, the community suddenly decided, we don't like that, we want you to dig it all up, put it in a lorry and drive it a long distance away and putting the hole in the ground in somebody else's community. That's what happened. That's an unpopular form of remediation. In California, where Deyi was talking about San Francisco, in a different city, in an urban setting, radioactive contamination was remediated by encapsulating it in a big monolith. And the remediation worked really well. When the surrounding community over the years changed, people moved out and so on, and new people came in, they realized what this lump in the middle of their community was. They said, we don't want radioactivity in the middle of our community. There was no problem, no risk, but the decision was taken to go in and break this monolith up and take it somewhere else. So those are unsustainable forms of remediation.
Yeah, please remove it from our line of sight. Doesn't really deal with it, does it? So
we're not managing risk.
No, exactly. Yeah, no, that's great. Thanks, Paul. I've got a question come in. I've got a couple more, but I'll save those for later. So, how much do you consider nano remediation as a successful in situ remediation technique for soils? So any of you got any experience with nano remediation or any examples that you know about?
We've been involved in an EU funded project called NanoRem, but I'll let Deyi answer first because I know that China's doing a lot of work on nano remediation.
Yep.
Yeah, so for nano remediation, there's a lot of research going on. My research group has developed a few variants of nanomaterials for remediation purpose. So I think in that regard, I mean, it's highly popular. But for actual project, it's still quite limited. I mean, for example, when I did one project in the US for the reductive remediation of a contaminant site, we look at the CVI, but at the end we didn't choose nano CVI because it was 4 times more expensive than the traditional the macro CVI, so we didn't choose it. There are also cases where in China we did look into it, but I mean at the end the business decision often relies upon the cost, and I think right now the cost is still not favorable for nano remediation quite often.
Yeah. Okay, so it's has it been proven as successful, but at the moment it's the cost implication that is.
I think the position in Europe is a bit different, and the position in the UK is very different. So I'll answer the European one first. The EU funded a project called NanoRem, and I'd encourage you to look at the website on NanoRem. If you can't find it, drop me an email. There are a number of bulletins looking at the performance of different nanoparticles, including nano zero valent iron that Deyi referred to, and how they've performed on real sites in a number of countries in Europe, and they all worked, they all did the job. Our role in the project, given that this was the first time that they were being injected into groundwater that was polluted, was to provide a risk assessment that showed that these nanoparticles would not themselves cause the level of adverse impact that I talked about as being unsustainable. And we did that qualitatively before it happened to satisfy the regulators, and then quantitatively when we had results afterwards to show that things were okay. In the UK, we currently are not allowed to use nanoparticles for remediation. There is a moratorium that's been in place for several years. And I think that nobody has bothered to go back and look at the fact we now know a lot more, and therefore that moratorium can be lifted. But that's where we are in the UK.
Okay. No, it's really helpful. Thanks both. It's really interesting thinking about the context. And again, there's another question about other kinds of legal and institutional priorities. So you mentioned this, Paul, in your talk as well. So this is a question specifically about local authorities and whether you think that they should require the evaluation of the sustainability of proposed remediations as part of their contaminated land strategies.
Is that a UK specific one? Or
yeah, that's a UK specific one, I think.
Okay.
It mentions local. Yeah. Well, I mean, I guess it could also be relevant for non-UK.
Okay.
Local,
well,
yeah, any local governance, I guess. So
I'll take that, but I'd be interested to see how you think the Sustainable Development Goals are making a difference worldwide. But in England specifically, the National Planning Policy Framework requires development to be sustainable development. So the local authorities already have a responsibility and a duty to consider a planning application to see whether it constitutes sustainable development or not. They have no choice.
yeah.
Most development, though, isn't just about the remediation. It's remediation as an enabler of something else, and it's the something else that has to be sustainable, and the remediation is part of the bigger picture. So that's something that I've talked about elsewhere. There's another EU project called HOMBRE, HOMBRE, that looked exactly at that, and we were greedy. We wanted our remediation to deliver more than just risk reduction. Material reuse, using the volume that's been created when you're excavating, that kind of thing. So have a look at HOMBRE if you want. But in the UK, it has to be sustainable development if you're going to get planning permission.
Okay, yeah, thanks. That's really comprehensive answer to that. A couple of other questions come in. Sorry, I'm just having a look through. So there's one actually linked to, so we mentioned SDGs. Obviously, another buzzword is soil health at the moment. So there's currently a lot of interest in soil health. So do you think sustainable remediation addresses restoring the health of the soil as a living thing under that context? For both of you to answer. So
yeah, Paul, do you want to go first or?
No, I'll let you go. I was hoping I had some coffee left in my mug, but
yeah. So it's becoming a new buzzword, I guess. So in China, the Ministry of Environmental Protection changed its name to Ministry of Ecology and Environment. This changed several years ago. And since then, people have been wondering, especially the policymakers, right? I mean, we are the Ministry of Ecology and Environment. What do we do about the ecology? Because in the past, it's always about pollution prevention and remediation. So now for the soil part, the policymakers are increasingly looking at soil health. And in fact, my research group has get some a pretty big funding recently to study soil health and its relevance to soil pollution. So I think this is a new trend and reflect what people are looking at systems from a broader view and look at soil as a living system rather than just some mineral material. Yeah. So I think this has implications for remediation. In the past, especially in China, high treatment under high temperature, like incineration or co-processing with cement manufacturing, was very popular. But that treatment inevitably destroy the biodiversity in soil and change the physical chemical properties. It was totally okay in the past, but I think looking into the future, this will become less favorable. And my hope is that this will help to promote a more sustainable alternatives in the remediation industry.
Yeah.
Jack, I know we're running out.
Have you got a very brief comment to finish?
It depends on what you mean by soil, and it depends on what you mean by health. Soil is more than just a living system. This is probably going to get me kicked out of the society. Because the soil underneath my house's principal function is to stop my house collapsing. And we need to recognize that health means different things in different places because the soil is doing different things for us.
Yeah, yeah. No, well, that's a great point to finish off on, actually. So I think thinking about that kind of multifunctionality and the lens at which we look at soils is really important. So no, but thank you both really very much. I'd like to thank you on behalf of the Society of two fantastic presenters, Paul and Deyi, today for coming along to present. And thank you everybody on the call for attending. You'll find a quick feedback form when you leave the webinar, so please take the time to just fill that in. As we mentioned at the beginning, a recording will be available after the event, so that will be available on our YouTube channel. Just want to highlight a couple of upcoming events. Obviously, our annual conference is at the end of the year. So this takes place on the 4th and 5th of December in Belfast. We've got a brilliant programme, so please do check the website there, and you'll be able to register for that event too. We really look forward to seeing you. We're also running another training course in November. So this is an agricultural land classification course that will be based at Cranfield University on the 22nd and 23rd of November. So again, do check out our website, and there's details there on how to book. Our next webinar, which will be the final one for this year, is on Wednesday, the 1st of November. Please do put the date in your diaries. The topic has been to be confirmed, so check the website and also register for that ahead of time. And yeah, just finally, I hope to see you at all these future events, and thanks very much for attending, and goodbye.